Hello everyone! Rico once again and welcome back to another episode of MATHFLEX. So I just want to start this video with a disclaimer. So just because I am doing this MATHFLEX channel, so some of you might think that I am a math genius or a mathematician. So just to set the record straight now, so I am not a mathematician and also I am not a math genius. So I think if there's such a thing as mathematician spectrum, so I won't even be within that range. So I just don't know. I feel like I'm overrated when they call me mathematician because I'm very far from being one. I think it's just so happened that when I was studying, math was my strength. I was a little bit excelling in math. But other than math, I was an average student in our class. So for today, let me share you how I improve my problem-solving skills as far as math is concerned. The first one is you have to know the concept of the lessons. I think this applies to all. You cannot troubleshoot the machine if you don't know how the machine works, and also if you don't know what the function of each part of the machine. Same also with math. You cannot have a clear understanding of the lesson unless you don't know the concept behind. Say for example, in this problem, you are asked to find the zeros of the function. So if you don't know the concept of finding the zeros of the function, you will end up staring at the problem. But if you know that finding the zeros of the function is like finding the value of x to make the equation 0, you can solve now the problem by applying different methods, either by factoring, or by synthetic division, or by quadratic formula. Or even the least thing that you can do is you can assume values of x that would make the equation 0. Knowing what's being asked will give you so many options or so many solutions to solve the problem. Second thing is do not memorize the solution. I think many of the students fail in their math exams because they memorize the solution. Memorizing the solution will not improve your math solving skills. You know, the danger of memorizing the solution is that when your professor tries to make a little twist of your exam, so what you will do now, if you memorize the solution, is you will try to fit in the solution based on what you have memorized. So memorizing the solution will not allow you to think out of the box solution. So instead of memorizing, so what you can do is to resolve all the problems given to you during the lecture. This will somehow help you on how to approach each problem given in the exam. The third one is you should make your own notes. Personally, taking pictures of the lectures or photocopying the notes of your classmates will not help you improve your math solving skills. And it's not even a smart idea. The reason there is that you will tend to relax and not to focus on the lesson because at the back of your mind is you will capture everything by picturing the lecture or by photocopying the notes of your classmates. Making your own notes will enable you to pay attention and capture the key concepts of the lessons. In case that you don't have time to copy what is all being written on the lecture, so you just have to copy the problem and the answer. So when you reach home, try to resolve the problem to arrive with that answer. The fourth one is try to derive the formula. I know that this is quite an advance for you, but you will appreciate more math once you know how the formulas are derived or where they came from. So the retention in our memory is more when you know how to derive the formula rather than just merely memorizing them. So the last one, and I think this is common tips to all, practice, practice, practice. All skills are being honed through constant practice. Don't just limit yourself on those problems given to you during the lecture. So try to solve as much problem as you can. As they always say, practice makes perfect. So these are some of my tips on how we can improve our math solving skills. So the first one is you have to know the concept. Second one is do not memorize the solution. Third one is you have to make your own notes. Fourth one is try to derive the formulas. And the fifth one is practice, practice, practice. So I think that's it. And let's go directly to our board work. So back to our board work. So the topic today is variation problems, and this is part of our word problem series. So we have three types of variation. So the first one is you have a direct variation. Second one is inverse the variation. And the third one, you have the joint or combined variation. So we'll have an example of each later on. So what is direct variation? Direct variation says if you have a value of y which is directly proportional or varies directly, okay, with x. You can have it like this: y varies directly with x. So k here is the proportionality constant. So for inverse, you will find like y varies inversely or inversely proportional to x. So to remove the proportionality sign, you have y varies inversely with x. So joint it's a combination of direct and inverse. So you can find it like y varies directly with x and inversely with z. So therefore you can write it as y is equal to k x over c. So let's try to solve more examples to illustrate these three types of variation. So let's try this problem. It says if y varies directly as x and x is equal to 9 when y is equal to 15, find y then when x is equal to 13. So actually you can solve this one by ratio and proportion. But for today, let's just solve it using our proportionality constant or variation constant. So the first thing that you should do if you see problem on variation is first you have to write the general equation. Say if x or if y varies directly as x, so that means you have your variation equation which is y varies directly as x. So k here, as I mentioned before, is our proportionality constant. And then the second is you have to plug in the first condition. So it says x is equal to 9 when y is equal to 15. So x is equal to 9 when y is equal to 15. Okay? So the first condition will give you the value of your proportionality constant or the k value. So solving for k now, so k then is equal to 15 over 9, or reducing that to lowest term, so that would be by 3, 5 over 3. So we have a k value which is 5 over 3. Next, so find y when x is equal to 33. So therefore, you can now find the value of y because you know the value of k which is 5 over 3. So y then is equal now to 5 over 3 when x is equal to 33. So that means you have to put or you have to plug in the value of x, which is 33. So this will cancel, this will cancel, so that's 11. So y then is equal to 55. So our answer here is letter D. So let's try this another problem. The cost of a pizza varies directly as the square of its radius. So if a pizza with a 6-inch radius costs $8, so how much should a pizza with an 11-inch radius cost? So from the first statement, you can find, or you can write your general equation. It says the cost of a pizza, so that is C, varies directly, so your proportionality constant, K, with the square of its radius. So this is our general equation now. Okay? The next thing is you have to plug in the first conditions. So it says if a pizza with a 6-inch radius costs $8, so that means you have the cost of 8 with a 6-inch radius, so that is K, and then you have 6 square. So as we mentioned before, the first condition would give you the value of your proportionality constant, or K. So K therefore is equal to 8 over 36. 6 squared is 36. So reducing this term, this fraction to lowest term, so that will be 2 over 9. So divided by 4, so that's 2 over 9. So you have a K value which is 2 over 9. And then you can find out the cost of a pizza, okay, because you know now the value of your K, which is 2 over 9. If the radius is 11 inches, so what would be the cost of your pizza now? So the cost of 11-inch pizza will be 2 over 9, so that is your K, and then a radius of 11 square. Okay, so therefore the cost is, let's have some calculator here. Let's try to calculate this one. So 11 times 11, 11 square times 2 divided by 9. So the answer here is $26.88. So in this case, our answer is letter B. Okay? So let's go to our next problem. So the next problem is an example of joint variation. So which means that it's a combination of direct and inverse variation. So it says, given that W varies directly as the product of X and Y, and inversely as the square of Z, and that W is equal to 4 when X is equal to 2, Y is 3, Y 6, and Z is 3. So find the value of W when X is equal to 1, Y is equal to 4, and Z is equal to 2. So again, the first statement will give us the general equation. So it says W varies directly, so we have to write first our proportionality constant with the product of X and Y, and inversely as the square of Z. So the second statement, we can derive the value of K. So when W is equal to 4, X is equal to 2, Y is equal to 6, and then Z is equal to 3. So you can derive now the value of K by plugging in these values. So you have 4, K, and then you have X, that's 2, and then that's 6, Y is 6, and Z, which is 3, square. Okay? So solving for K here, so you have here 9. So 9 times 4 is 36. It's equal to K, so that's 12. So therefore K is equal to 36 divided by 12, so that is 3. Then since we know the value of K, so we can have our equation as K, which is 3 XY over Z squared. So plug in now the values of the second condition to get the value of W. So W here is So that is 3, that's our K, and then 1, and then you have a value of 4 for Y, and Z, which is 2 squared. So this is 2 squared is 4, so that's cancel here, cancel there. So our value, or the value of W is 3. So in this case, our answer is letter A. So let's try this last problem, and it's an application of variation problems. So the time required for an elevator to lift a weight varies directly with the weight and the distance to which it is to be lifted, and inversely as the power of the motor. So if it takes 30 seconds for a 10 horsepower motor to lift 100 pounds through 50 feet, so what size of motor now is required to lift 800 pounds in 40 seconds through 40 feet? So the problem is very long, but if you try to digest it, it's somehow related or the same with the previous examples. So again, let's try to establish our general formula. So the time, so that's T, required for an elevator to lift a weight varies directly with the weight. So we have to write our proportionality constant with the weight, and the distance through, so that's the distance through which it is to be lifted, and inversely as the power of the motor. So this is now our general equation. So the first condition is if T is equal to 30 seconds, okay, and the power is 10 horsepower, and the weight is 100 pounds, and the distance is equal to, okay, is equal to 50. So we can derive now the value of K. So by substituting these values, so you have 30 is equal to K, W is 100, times a distance of 50, and a power of 10. So that is, this is 5 there, so that's 5. So K is equal to 30 over 500. So by 10, that is, let's keep K value as 3 over 50. Okay? So we were able to find the value of K, which is 3 over 50. So you have a general formula now, which is 3 over 50 WD over P. So now we have to substitute the value of the second condition. So condition, the time is 40 seconds, and that's 3 over 50 here, times the weight now is 800, times a distance of 40, and the power is unknown. So we'll try to work on these values using our calculator. So let's try to cancel, if we can cancel some. So this cancel, this cancel. So that is 50 there. So this cancel, so 800 divided by 50, so that's 16. Okay, so this will go there. So P there is equal to 3 multiplied by 16. The power needed to lift the elevator is 48 horsepower. So in this case, our answer is letter D. So that's it for today. Again, we have this problem for you to solve, and comment down below if you have an answer for this problem. So don't forget to watch, like, subscribe, and hit the notification bell for you to get updated on our succeeding videos. Until next time, bye-bye!